Continuing our look at systems of linear equations, we're now going to look at how to solve them using the technique of elimination. As a reminder, we will eventually look at 4 techniques for solving a system of linear equations. The first technique we saw in the previous video lecture, which was substitution. Here we're going to be solving them by elimination. We will then look at graphing. And finally, we will look at how to solve them using matrices. So on to elimination. What do we want to remember about this? We want to remember that we know what a system of linear equations is. It is a collection of 2 or more linear equations. And for the most part, we're going to stick to 2 linear equations in 2 unknowns. We'll go to 3 equations and 3 unknowns in future video lectures. So here's an example. Remember, this curly bracket or brace indicates we have a system of linear equations. Equation 1, 2x plus y equals 5. Equation 2, negative 4x plus 6y equals negative 2. So this is 2 equations in 2 unknowns, and those 2 unknowns are x and y. So how do we solve a system of linear equations by elimination? Well, we do the following. Let's first talk about what elimination means mathematically. The word elimination means to remove. So what we're going to be doing, we're going to remove a variable by adding it to its opposite, which will give us 0. Something plus its opposite is 0, and we have none of it. We've removed it. We've eliminated it. So how do we solve by elimination? Well, we want to multiply one or both equations by a constant so that the coefficients of one of the variables are opposites. Because when we add opposites, that we wind up with 0, and that eliminates it. Step 2. Add those equations together. This removes one of the variables because they're opposites. We will then solve the remaining equation. Step 3, use one of the original equations to solve for the remaining variable or the other variable. And then step 4, of course, whenever we're dealing with equations, we can always check to see if our solution is correct. We do this with a system. We check our solution in each of the equations we're talking about. It must work for both in order to be a solution of the system. So let's do it. I got a couple of examples here. I think you'll find this to be fairly straightforward. Example 1, we want to solve this system, the system of 2 equations and 2 unknowns. 2x plus y equals 5 is equation 1, and negative 4x plus 6y equals negative 2, we'll call that equation 2. So, we want to multiply one or both of these by a constant so that we have the opposite coefficient of x terms or the opposite coefficient of y terms, because when we add, we'll get 0. I'm going to choose to multiply equation 1 by 2. If I multiply equation 1 by 2, the x coefficient is positive 4, and a positive 4 is the opposite of a negative 4, and that will 0 out the x's when I add. You could choose to multiply equation 1 by negative 6. Because when you multiply the coefficient of the y, which is 1, by negative 6, this coefficient, negative 6, will be the opposite of this coefficient, positive 6. And when we go to add, we'll have 0 y's, which will eliminate the y. I'm going to choose to eliminate the x's. Multiply equation 1 by 2. So here's how I do this. I take the first equation and I rewrite it. I rewrite the second equation. Okay, and then I say, well, the first equation, I'm going to multiply by I'm going to multiply by 2. The second equation, I'm simply going to copy. So I'll multiply both sides on the first equation by 2. It doesn't change the fact it's an equation because I'm multiplying everything by the same number. So the first equation becomes 4x plus 2y is equal to 10. Multiplying every piece of the first equation by 2. The second equation I just copy. Negative 4x plus 6y equals negative 2. I just copy in this case. Okay, now notice I have coefficients of one of the variables that are opposite one another. That is the goal. You can choose the x variable or the y variable. I chose to make the x variable coefficients opposites. Step 2, let's add these equations together. Left side plus left side, right side plus right side, and then we'll solve the remaining. Okay, so I have equation, here's 4x plus 2y equals 10, and here's negative 4x plus 6y equals negative 2. Let's add these together. I'm going to add them. Okay, left side plus left side. Well, 4x and negative 4x is a big old 0. 2y plus 6y is 8y. Left side plus left side. Right side plus right side. 10 plus negative 2 is negative 8. Excuse me, it's positive 8. I saw the negative and got myself confused. It's positive 8. Okay, now I'm going to solve this. This is pretty easy. Divide both sides by 8, and I come up with y is equal to 1. Okay, now step 3. We know what y equals. We need to solve for the other variable. We need to solve for x. So you can choose, always go back to the original. You can choose either original you want to come up with x. I'll choose equation 1. So I'll choose, come down to here. I'll choose equation 1. Doesn't matter, you can choose equation 1 or equation 2. Equation 1 says 2 times x plus y. Well, y is 1, so I'll put 1 in for y is equal to 5. Now I have one equation and one unknown. I can solve for x. Subtract 1 from both sides. Divide both sides by 2. And so my solution is x equals 2, y equals 1. If I want to write it as a point, it's the point 2, 1. We'll talk a lot more about that coming up, okay, because we're going to solve them graphically, and that's going to be our intersection point. So again, I think my solution is 2, 1, x equals 2, y equals 1. Now I feel pretty good about that, but we can always check. Okay, we check by using the original equations, putting these two in there, and it should work for both. So equation 1, again, is 2x plus y equals 5. Let's substitute in for x. Let's put in 2. In for y, we'll put 1. Do we get 5? That's a question. Well, 4 plus 1 is 5. We do get 5. My solution, x equals 2, y equals 1, works for equation 1. I just checked it. Now let's check equation 2. As a reminder, your solution must work for all equations in the system in order to be a solution of the system. Okay, equation 2. Equation 2 is negative 4x plus 6y equals negative 2. Let's put in 2 for x, so negative 4 times 2. Let's put in 1 here or here for y. 6 times 1. Does this equal negative 2? If it doesn't, I have a problem. Negative 8 plus 6 is indeed negative 2. It checks out in the second equation. It checks out in the first equation. So my solution I feel very good about. My solution is x equals 2, y equals 1. All right, we'll do one more example of that. Example 2 here. Okay. Solve the system 3x minus 6y equals 2, equation 1. And 5x plus 4y equals 1, equation 2. Just in case I make use of them, I'll label them 1 and 2. Okay, now it looks like I can't multiply 1 or 2 by itself to get opposites. But I can multiply 1 and 2 by something, so I can multiply both equations by a constant to get opposites. Now, so you're looking for is basically what's called the lowest common multiple. So if I multiply the top equation by 5 and the bottom equation by negative 3, I'll have 15 and negative 15. That would work. Or I notice that my y's are already opposites. One's a negative, one's a positive. They already have opposite signs. So I can multiply the top equation by 2 and the bottom by 3, and I wouldn't have to deal with a negative because it would come out. Negative 6 times 2 is negative 12. Positive 4 times 3 is positive 12. So I'm going to choose, I'm going to multiply 1 by 2. And I'm going to multiply equation 2 by 3. Because I'm going to get my y's to be opposites in this case. Okay, so let's copy down the original. I'll multiply this one by 2. And this one by 3. Again, I'm focused on my y's. The lowest common multiple of 6 and 4 is 12. 6 times 2 is 12. 4 times 3 is 12. They're already opposite signs, and so my y coefficients will be opposites if I do that, and I can then add and get a 0. So multiply the top equation by 2, and I have 6x minus 12y is equal to 4. Multiply the bottom equation by 3, and I have 15x plus 12y is equal to 3. There you have it. I want opposite coefficients for one of the variables, and I have it. Step 2, let us add these equations together. Okay, so my equations are, so add equations together. Then solve. That's step 2. Okay, so I've got 6x minus 12y is equal to 4. I've got 15x plus 12y is equal to 3. Okay, I'm going to add them. Well, left side times left side plus left side, negative 12 and positive 12, no more y's. Excellent. 6 and 15, I have 21 x's on the left side, and 4 plus 3 is 7. Now let's solve. Divide by 21. X is equal to 1/3. Okay, step 3. Okay, use one of the original equations to solve for, in this case, I want to solve for y, because I already know what x is equal to. Let's use one of the originals. Let's see here. X is 1/3. I'm going to choose equation 1 because 3 times 1/3 is a 1. Makes it nice and easy. So I'll choose equation 1. Okay, so 3 times, I'll put this as equation 1 here. 3 times 1/3 minus 6 times y is equal to 2. You'll notice I have one equation and one unknown. This can be solved. 3 times 1/3 is 1. Let's subtract 1 from both sides. Let's divide both sides by negative 6, and y is equal to negative 1/6. So I think my solution is x equals 1/3 and y equals negative 1/6 as a point. Again, we're going to do graphing in our next video lecture. The point is -1/3, comma, -1/6. Again, let's check. Okay, so let's check. Let's check equation 1. This should work if it goes into equation 1. Again, this needs to work for both equations or all the equations in the system in order to be a solution of the system. Equation 1 says 3x minus 6y is equal to 2. Let's put 1/3 in for x. Let's put -1/6 in for y. Does this equal 2? Well, this is 1. This is plus 1, so that indeed equals 2. My solution works in equation 1. Again, it needs to work in both or all equations in order to be a solution to the system. So let's check equation 2. This is equation 2. Let's replace the x with positive 1/3. Let's replace the y with -1/6. Does this equal 1? I'm not going to do that mentally. I'm going to pull out a calculator. And let's see what my calculator tells us. 5 times 1/3 plus 4 times -1/6. Do I get 1? I do. Okay, so I got 1 is equal to 1. I feel good that the solution 1/3 -1/6 is the solution to my system. And as a reminder, when we have a solution, one or more solutions, the system is consistent. We have a consistent system. So there you have it, solving by elimination using these steps. Next up, we're going to talk about how to solve a system of linear equations by graphing.